is equal to dv by dt. Okay, I hope everyone knows this. So, yeah, our first question is this is our first question. Okay. Okay. The velocity of a particle is given v equal to v0 plus gt plus ft square. Its position is x is equal to 0 at time t equal to 0. Then its displacement after time t equal to 1. See, we have given velocity v0 plus gt plus ft square. Okay. Okay. So see, we have to find the displacement. Okay. So we should derive an equation of relating displacement and time. So velocity we can write as dx divided by dt equal to v0 upon gt plus ft square. So I'm taking dt on the right hand side. So dx will be v0 dt plus gt dt plus ft square dt. Okay, so by integrating this left hand side and right hand side, x will be v0 into t plus g into t square by 2 plus f into t cube by 3. Okay, then see, given as at time t equal to 1, what is the displacement? So see, x is equal to v0 into time is 1. So v0 into 1, v0 plus g by 2 into t square, g by 2 into 1 square, g by 2 plus f by 3. Right. So this will be the answer. So v0 plus v0 plus g by 2 plus f by 3. So this will be our option 2 is the right answer. Okay. Next question. Okay. A particle is moving with a speed v equal to b root x along positive x-axis. Calculate the speed of the particle at a time t equal to tau. Assume that the particle is at origin at time t equal to 0. Okay, it's given. So velocity, we have given velocity equal to b root x. We have to find out speed of the particle at time t equal to tau. So we can write dx upon dt, velocity is equal to dx upon dt b root x. I'm taking dx upon root x. See, it equal to p dt. Okay, by integrating this, okay, integral dx x raised to minus 1 by 2. Root x we can write as 1 by root x we can write as x raised to minus 1 by 2. Integral b dt. Yes. So this will be 2 root x equal to bt. Yes. So squaring both side, by squaring both side, by squaring both side, x equal to b square t square upon k. To calculate the speed by differentiating x, we will get velocity b square by 4 into d by dt of t square will be 2t. 2 we can cut. So we will be b square by 2 into t. So its question, it's given time t equal to tau. What is the value? What is the speed? So speed will be b square by 2 into tau. So this is the, see, this is the correct option. Okay. B square tau by 2. Yes. Next, our third PO. Yeah. The position of a particle as a function of time is given by x is equal to at plus bt square minus ct cube, where a, b, and c are constants. When the particle attains zero acceleration, then its velocity will be. Again, we have to differentiate this equation, then we will get velocity. Again, differentiating, we will get acceleration. From acceleration, yeah. So x is equal to at at plus bt square minus ct cube. By differentiating this, we will get velocity as a plus a plus a plus 2bt minus 3ct square. Yes, then acceleration will be 2b minus 6ct. Okay, it's given when the particle attains zero acceleration, then its velocity will be. So when particle attains zero velocity, we can write 2b minus 6ct equal to 0, then 2b equal to 6ct, then we will get an equation for time. No, we will get time at which acceleration is 0 will be 2b upon 6c, that is b upon 3c. That is b upon 3c. So we got the time. Then we have to just insert this time into velocity equation. Then we will get velocity. So we equal to a plus 2b. Time is b by 3c minus 3c into b square will be b square upon 9c. So velocity as a plus 2b square by 3c minus, here 1c we can cut, b square by 3c. V equal to a plus b, 2b square minus 2b square by 3c minus b square by 3c will be b square by 3c. So velocity is a plus b square by 3c. So yeah, this is the correct option. Okay. Yes. Next is types of motion. Yeah. We have three different scenarios. First one is non-accelerated motion. Second one is uniformly accelerated motion. Third one is non-uniformly accelerated motion. Non-accelerated motion, yeah, A will be 0. If A is 0, then velocity will be displacement upon time. Simple equation, and distance displacement will be velocity into time. Easy. If A is constant, we have three equations. V is equal to U plus AT, S is equal to UT plus half AT square, and V square minus U square is equal to 2AS. And if acceleration non-uniformly accelerated motion, acceleration is not constant. So we have to use calculus here. Okay. And displacement in nth second. Displacement in nth second, we have a formula, we have an equation. Displacement in nth second, as nth is equal to U plus A by 2 into 2n minus 1. U plus A by 2 into 2n minus 1. Okay. Yeah, this is the next question. Okay. I'm reading the question. A car accelerates from rest at a constant rate alpha for some time, after which it decelerates at a constant rate beta to come to rest. The total time elapsed is t seconds. The total distance traveled is. Okay. A car accelerates. See, a car accelerates from rest. Rest at a, so you will be zero here. A car accelerates from rest at a constant rate alpha. So up to t1 second, its acceleration is alpha. Then which it decelerates at a constant rate beta. So for t2 time, its acceleration or its deceleration is beta. Then it's come to rest again. When it's come to rest again. Okay. And it's given if the total time elapsed is t seconds. So t1 plus t2 is t. Okay. You have to find out the total distance traveled is. Okay. See. Okay. So v equal to u plus at. We know that equation. So here u is 0. So the velocity at here will be v equal to alpha t1. Easy. So t1 will be v by alpha. T1 will be v by alpha. Okay. Then from here to here, the equation will be velocity v is equal to u plus at. Here final velocity is 0. Initial velocity is again v. Okay. So 0 equal to v minus beta t. Okay. Why minus? It's decelerating. So negative sign. So here we will get t2 as v by beta. T2 as v by beta. Okay. So we know that total time t equal to t1 plus t2. So time t equal to v by alpha plus v by beta. From here, we can 1 by alpha plus 1 by beta. That will be alpha plus beta by alpha into beta. So we will get an equation for velocity v equal to alpha beta t divided by alpha plus beta. Okay. So we got an equation velocity v equal to alpha beta t divided by alpha plus b. Okay. And from C, A, B, C, from A to B, the distance covered S1 equal to ut plus half at square, u is 0, half alpha t1 square. Okay. And half alpha t1 is v by alpha. So v square by alpha square. We got v square by 2 alpha. Okay. And S2 will be, S2 is the distance from B to C. Again, ut plus half at square. Here ut is v into t2 minus half beta t2 square. Okay. So v into t2 is v by beta minus half into beta. T2 square will be v square upon beta square. So v square upon beta minus v square upon 2 beta. It will be again v square upon 2 beta. So we got s is equal to s2 is equal to v square upon 2 beta and s1 equal to v square by 2 alpha. Okay. So total distance, we have to find the total distance, right? So s is equal to s1 plus s2, that is v square by 2 alpha plus v square by 2b. Right. So from here, v square by 2 1 by alpha plus 1 by b. Okay. So S is equal to we have an equation for velocity, right, in terms of time, alpha beta t. So you have to equate that equation here. So alpha square beta square t square alpha plus beta whole square into 2, right, into alpha plus beta by alpha into beta. So alpha plus beta, 1 alpha plus beta we can cut here, 1 alpha, 1 beta we can cut here. So S will be alpha beta t square divided by alpha plus beta into 2. So alpha beta t square divided by 2 in alpha plus beta. So answer is option number 3. Answer is option number 3. Yeah. This is our next question. In a car race on a straight road, car A takes a time T less than car B at the finish and passes finishing point speed V more than of car B. Both the cars start from rest and travel with constant acceleration A1, A2 respectively. Then we have to find out the velocity V. Again, very simple. Okay, we can start like this. Okay. See. So a car A. First we can read car A story. See, car A start from here. Car A start from here. And suppose this is the finishing line. This is the finishing point. This is the finishing point. Okay. Car A takes finishing point. Okay. So both the cars were reaching at same finishing point. So this is car B. Okay. And suppose so they cover car A takes it. Both the cars start from rest. Okay. So both the cars travel same distance as a car race. It's a car race. Okay. And so suppose A's acceleration is A1 and B's acceleration is A2. And A finished at a finish with a velocity V1 and B finished with velocity V2 and A finished in time T1 and B finished in time T2. Okay. And it's given in question. Car A takes A time E less than car B. Okay. That means T2 minus T1 is T. T2 minus T1 is T. 2 minus T1 is T, right? Car B's time is T2, car A's time is T1. T2 minus T1 is T. And V1 minus V2 is V. Means and passes finishing point with speed V more than that of car B. Okay. So we got two equations here. So V square is equal to U square plus 2S. From that equation, we can write V1 square is equal to, see, U is 0 for both the cars. V1 square is equal to 2A1S. Simple. So V1 will be root 2A1S. So same equation, V2 equal to root 2A2S. Okay. And S is equal to UT plus half AT square. U is 0. So S is equal to half A1 T1 square for car A. This is equal to half A2 T2 square for car B. Easy. From this displacement equation, We can write T1 as root of 2s by a1 and T2 is root of 2s upon a2. Simple. And we know that T2 minus T1 is T. So we can root of 2s by a2 minus root of 2s by a equal to right. From this equation we can write root of I am multiplying root a1 a2 both sides. So root of 2s a1 root of 2 a1s minus root of 2 a2s equal to t into root a1 a2. I just multiplied root a1 a2 both side. That's all. Okay. We know root a1s is root 2a1s is v1 and root 2a2s is v2. So v1 minus v2 is t into root a1 a2 and v1 minus v2 is actually the v. I have to find out the v. So v is t into root of a1 a2. Yeah. So the answer will be root a1 a2 into t. Yeah, this is the answer. Root a1 a2 into t. Okay. Yes. Next question. Next question is from a tower of height h. From a tower of height h. From a tower of height h, a particle is thrown vertically upwards with speed u. The time taken by the particle to hit the ground is n times that taken by it to reach the highest point of its path. The relation between the tower of height h and the initial velocity with which thrown is vertically, oh, the particle speed with which the particle is thrown vertically upwards, and the n is, yeah, how much, how many times? Okay, so you have to derive a relation between capital H, U, and N. Okay, first we can make a diagram. See, so from ground there is a tower. Its height is H. Height is capital H. A particle is thrown vertically upward with the speed U. Okay, so the particle follow trajectory like this. Easy. So here velocity will be zero at the highest point. So from starting point to the highest point, time taken is t1. Okay, time taken is t1. So from that, v equal to u plus at. So okay, I'm taking upwards as positive direction and downwards as negative direction. So final velocity is 0, u minus gt. So t1 will be u by g. T1 will be u by g. Okay, okay. And the total time taken from starting point to hit the ground is time t. Okay, so from that, from equation s is equal to ut plus half a t square. So from the starting point to finishing point, that's the where particle hit the ground. Displacement will be this much. That is minus h. See, downward direction we took as negative. So displacement is minus h, and yeah, initial velocity is u and time is t minus half into gt square. Okay, so G GT square. See, I'm multiplying both sides with 2. So minus 2h will be 2ut minus GT square. GT square equal to 2ut plus 2h. From this we can get GT square minus 2ut minus 2h equal to 0. Okay. So we have to find out the time t and we have to equate with this t1. That's the n. So minus b plus or minus root of b square minus 4ac by 2a. Okay. So using this formula, we'll get time t equal to 2u plus or minus root of b square or u square minus 4ac 4g then 2h means 8 8gh 8gh divided by 2 into a 2g. Easy. So t equal to 2 we can take as a common. So 2 u plus or minus root of u square minus u square minus 4ac. Oh, here it is minus 2 so plus u square plus 2gh divided by g. Easy. So t equal to u plus root of u square plus 2gh divided by g. And this time t is the total time taken from the starting point to hit the ground. So that we know that time taken by the particle to hit the ground is n times that the time taken by it to reach the highest point, that is t1. So we can equate this t equal to n into t1. T1 is u by g. T1 is u by g. Okay. So here we can cut g, and question will be u plus root of u square plus 2gh is equal to nu. And we can take u on right hand side. So root of u square plus 2gh equal to nu minus u is n minus 1 into u. N minus 1 into u. So we square on both sides u square plus 2gh equal to n1 n minus 1 square n minus 1 whole square into u square. Easy. U square plus 2gh equal to nu square minus u square. Okay. So nu square minus u square. Simple. Yes. So 2gh will be nu square minus u square minus u square. So 2gh equal to nu square. So u square is common everywhere. So u square into n minus 2. U square into n minus 2. U square into n minus 2. So we got 2gh as n minus 1 whole square. Okay, see. See, u square plus 2gh equal to n minus 1 whole square is n square plus 1 square minus 2n, right? Into u square. Okay, so u square plus 2gh equal to n square u square plus u square minus 2n u square. Okay, so 2j is equal to n square u square plus u square minus 2n u square minus u square. So upon taking u square as common, n plus 1, n plus 1 minus 2n minus 1. So here we can cut minus 1 plus 1. So u square n minus 2n. So u square, here we can take n common. That is, yeah. So the equation will be, answer will be 2gh equal to n square into n minus 2. Moving on to next question. Yes, our next question is, helicopter rises from rest on the ground vertically upwards with a constant acceleration g. A food packet is dropped from the helicopter when it is at height h. The time taken by the packet to reach the ground is close to.